Hello class, in the last lecture we discussed about the conditions required for alpha decay, then the range of alpha particle. So for that Geiger's law, Geiger-Newton's law, then we covered some discussion of Gammo's theory of alpha decay, some part is left. In the present lecture I am going to discuss about the remaining part of Gammo's theory of alpha decay, then beta decay disintegration energy. Yes, what is Gammo's theory of alpha decay? According to Gammo's theory, uh, the alpha particle has the wave nature because it's a de Broglie wave existing associated with it. Therefore, even though it has the less kinetic energy than the potential barrier, it has the probability to leak through the potential barrier. That effect is called tunneling effect. So Gammo explained the alpha decay process by using the concept of tunneling effect. So there some assumptions he has considered that alpha particle may exist as an entity within a heavy nucleus. The alpha particle is in the constant motion and bonds front and back with the walls of the barrier. In each bombardment with the wall, there is a definite probability that the particle will leak through the potential barrier. So if nu is the frequency of collision with the walls of the nucleus, then P is the decay probability per unit time, lambda equal to nu into P. And also, suppose it is a nucleus of radius capital R, then the distance covered between two successive collisions with the walls of the nucleus, then T is equal time taken 2R by V. So therefore frequency nu equal to reciprocal of time period, from that we have written V by 2R. So therefore nu is equal V by 2R, equation 2. So here by using the wave mechanics and the Schrodinger wave equation, Gammo explained the alpha decay process. So then we have taken the expression direct equation log P base E is equal minus 2 by h by 2 pi integral r to r1 square root of 2m into v of r minus t dr, equation 3. So where v of r is potential energy at the distance r from the center at the distance r, the potential energy V of r equal 1 by 4 pi epsilon naught 2e into Ze by r, that equal to Ze square by 4 pi epsilon naught r. Yesterday I told you that at the distance r is equals to r1. So what is that? Yes, this is the graph. This is the potential well. O is the center of the nucleus, r is the radius of the nucleus, right? So maximum potential energy V maximum, right? So where T is the kinetic energy of alpha particle. There at the distance r1 from the center of the nucleus, there potential energy equal to kinetic energy, that is 2 Ze square by 4 pi epsilon naught r1 is equal to T. From this we have written r1 equal 2 Ze square by 4 pi epsilon naught T. Okay. So here the concept is, according to classical physics, what we are telling is, since the alpha particle has the energy in the order 4 MeV to 9 MeV, but the height of the potential barrier is 26 MeV. So therefore there is no probability to leak through the potential barrier because alpha particle kinetic energy is very less compared to the 26 MeV. But quantum mechanics explains the penetration of the alpha particle based on the wave nature. Since the alpha particle is treated as the wave, therefore this is the nucleus, that is the potential barrier, right? Then alpha particle can penetrate through this potential barrier. So that we call it as tunneling effect. So for that I am writing the equation direct. Log p base e equal minus 2 by h by 2 pi integral r2 r1 square root of 2m into v of r minus t into dr, where v of r is the potential energy, t kinetic energy of the alpha particle. So that is written here, v of r equal 1 by 4 pi epsilon naught. By using the formula 1 by 4 pi epsilon naught q1 q2 by r. This is the potential energy of the system of two charges q1 q2 which are at the distance r. So here 2 is the charge of alpha particle, Ze, this is the charge on the nucleus of daughter nucleus by r. We get 2 Ze square by 4 pi epsilon naught r. But at r is equal to r1, that is at the boundary of the nucleus, at the boundary of the nucleus, there potential energy must be equal to kinetic energy, then only that can penetrate through this potential barrier. Therefore log p base e equal to minus 2 by h by 2 pi square root of integral capital R to R1 square root of 2m v of r equal to 2 Ze square by 4 pi epsilon naught r minus t into dr. Okay. So since v is equal to t, 2 Ze square by 4 pi epsilon naught r1 equals to t. From this you write tr1 as the subject, tr1 equal 2 Ze square by 4 pi epsilon naught. Substituting that we got log p base e equal minus 2 by h by 2 pi integral r2 r1 square root of 2m into t r1 by r minus t dr, right? So that equals to minus 2 by h by 2 pi integral r2 r1 by taking common by writing t outside square root of 2mt into r1 by r minus 1 into dr. So that equals to minus 2 by h by 2 pi. You write 2mt outside of the integral, 2mt whole power of integral r capital R to r1 square root of r1 by r minus 1 into dr. But this integral value capital R to r1, r1 by r minus 1 whole power of is equal r1 into cos inverse of capital R by r1 whole power of minus r by r1 whole power of into 1 minus capital R by r1 whole power of. So here when the thickness of the potential barrier is very much greater than the nucleus radius, that is r1 very much greater than capital R, then cos inverse of r by r1 whole power of is equal to pi by 2 minus capital R by r1 whole power of, and 1 minus r by r1 whole power of value nearly equals to 1. So substituting that value, log p base e equal to minus 2 by h by 2 pi 2mt whole power of into, so here r1 into pi by 2 minus r by r1 whole power of minus r by r1 whole power of. So here also r1. So what I am saying, log p base e equals to log p base e is equal minus 2 by h by 2 pi 2mt whole power of r1 into pi by 2 minus 2 r by r1 whole power of. But we have r1 is equal to Ze square by 4 pi epsilon naught t. So then by substituting that, log p base e is equal minus 2 by h by 2 pi, right, 2mt whole power of into, this is 2 Ze square by 4 pi epsilon naught t into pi by 2 minus 2 r by r1 we have 2 Ze square by 4 pi epsilon naught t whole power of. Okay, so this is equals to minus 2 by h by 2 pi 2m whole power of 2m whole power of 2 ze square by 4 pi epsilon naught t power of. So this capital T power of and T power of 1 T power of cancel. So here T power of left into multiplying into the bracket the first term pi by 2 plus 4e by h by 2 pi small m by pi epsilon naught whole power of z power of into r power of. So that gives 4e by h by 2 pi by simplification m by pi epsilon naught whole power of z power of r power of minus e square by h by 2 pi into epsilon naught m by 2 whole power of z t power minus of. Say this is equation 6. Here by substituting the Planck's constant, electron charge, m and epsilon, permittivity of free space values, then we will get the equation log p base e is equals to 2.97 z power of r power of minus 3.95 z t power minus of. Consider it as equation 7. Here you remember that R is in Fermi and the kinetic energy of alpha particle is in MeVs. But we have from equation 1 what? Lambda equals to nu into P. Lambda equal to, but we have nu is equal to V by 2R. Then this will be V by 2R into P. Taking logarithm, natural logarithm both sides, log lambda base E equal to log of V by 2R base E plus log P base E. Or you can write ln of lambda equals to ln of V by 2R plus ln of P. So this is equation 8. Substitute this log P value in this equation 8. So from 7 and 8 you can write log lambda base E is equals to log lambda base E equals to log p value 2.97 z power of r power of minus 3.95 z t power minus of plus log of v by 2r base e. Okay, by changing the base e into base 10 you have to multiply with 2.303, then you will get log lambda base 10 is equals to then log of v by 2r okay, v by 2r, so into 2.303, so here also into 2.303, dividing whole equation by 2.303, log lambda base 10 equal to log of v by 2r written the first plus 2.97 by 2.303 z power of r power of minus 3.95 by 2.303 z t power minus of. Then from this equation you will write log, from this equation we will write log lambda base 10 is equal to log of v by 2r base 10 plus 1.29 z power of 1.29 z power of r power of minus 1.72 z t power minus of. Say this is equation 9. So here I am writing it as log lambda base 10 is equal to c plus d t power minus of. So here c, this is total c, this one, d equal to this one, right? D z t power minus of z dz t power minus of, here d is equal to 1.72, where c is equal log v by 2r base 10 plus 1.29 z power of r power of, and d is equal minus 1.72. Okay, so this equation is in the form y equal mx plus c, right? If you take the graph between by taking z t power minus of on x-axis and log lambda base 10 on y-axis, you will get the straight line like this. Here because slope is negative, right? So that here so slope is equals to minus 1.72, and this represents c value log of v by 2r base 10 plus 1.28 z power of r power of, where c and d are constants. This equation shows that radio elements having the lesser decay constant emit alpha particles of greater kinetic energy, which is explaining the Geiger-Newton's law. It is very clear. So how to understand? So this on x-axis what we have taken z by t power of, right? If the half-life is more, z by t power of value is less. For lesser z by t power of value, we have the more log lambda value. So the radioactive elements having more of life have the have the more of life, then they will have the decay constant will be more. Is it right? So z by t power of, if t power of is more, t power of is less, z by t power of is more. For that log lambda is less value. Therefore, the elements having lesser decay constant or more half-lives will emit the more kinetic energy alpha particles. So that was explained by the Geiger-Newton's law. Therefore, gamma theory explained qualitatively the essential feature of alpha decay, but only the main drawback of this theory is assumption of free existence of alpha particle in the parent nucleus. It is not likely to be correct. So the comments about this Gammo's theory are: number one, the graph between log lambda versus 1 by V alpha is a straight line. So this is a good agreement with the experimental result. The second one, the values obtained for the radius are good agreement with the calculation r equal r naught a power 1 by 3. So the values calculated for the radius are good agreement with the formula r equal r naught a power 1 by 3. So therefore, Gammo's theory of alpha decay qualitatively explained the alpha decay process at Geiger-Newton's law. Right. So now coming to the decay or beta disintegration. So what is beta decay? Let me repeat the concept. Beta decay is nothing but the emission of beta particle by the radioactive substance, right? So its generally representation ZXA gives rise to beta particle, that is minus 1 beta 0 plus Z plus 1 YA plus antineutrino. So this we call it as beta minus decay, right? Or ZXA gives rise to plus 1 beta 0 plus Z minus 1 YA plus neutrino. This is called beta plus decay, right? Or ZXA plus electron gives rise to Z minus 1 YA plus neutrino. This is called electron capture. Electron capture. So beta decay processes are of three types: beta minus decay, beta plus decay, electron capture. In these three processes, we will calculate the disintegration energy Disintegration energy is nothing but the energy released in the beta decay process. Here this is the parent nuclide. This is the what is this daughter nuclide. So emitted particle beta, here some other particle antineutrino. Now the total mass of this beta daughter nucleus and nu bar will be less than the mass of the parent nucleus. So there will be mass defect in these three reactions. So the mass defect since taking place according to Einstein mass energy relation equal to mc square, then the equivalent amount of energy can be liberated in that process. So in beta minus decay, beta plus decay, electron capture, in these three processes, energy is liberated. That energy is called beta disintegration energy. So let us see one by one. In the first, you consider beta minus decay process. So for that, what reaction we have? ZXA gives rise to minus 1 beta 0 plus Z plus 1 YA plus antineutrino. Or you can write it as ZXA gives rise to minus 1 beta 0. You can write minus 1 E0 plus Z plus 1 YA plus antineutrino nu bar. So by neglecting this one, you can write ZXA because its mass, rest mass is 0, gives rise to minus 1 E0 plus Z plus 1 YA. So here ZXA is the initial nucleus. It is initial nucleus or parent nucleus. This is daughter nucleus or final nucleus formed after disintegration. Okay, this is the electron. Let us consider their nuclear masses. Its mass, I am writing m of mn of ZA, right? Electron mass say me, and final nucleus mass mn of A Z plus 1. Okay. Then we can write mass defect. Mass defect is nothing but what? The total mass of the products minus mass of the parent nucleus or initial nucleus. So delta M is equals to, that is Mn of A Z plus 1, this mass minus this mass. Delta M is equal to Mn of ZA, because initial mass is more than that of the masses of products. So mass defect is forming, hence energy is liberating. Mn of ZA minus Mn of A Z plus 1 minus Me. Okay. So from Einstein mass energy relation, that is equal to mc square. If mass m is destroyed, the equivalent energy liberated mc square. If any nuclear reaction mass m is created, then mc square amount of energy will be absorbed, where c is speed of light 3 into 10 power 8 meter per second. So energy annihilated, energy liberated or absorbed in any process is equal to m into c square, or the equivalent energy to the mass m is equal to mc square. So for the delta mass equivalent energy, that is called disintegration energy, q beta minus 1 equal to delta m into c square. Therefore, the disintegration energy in the beta decay process, q beta minus is equals to Mn Az, that is what? Parent nucleus or initial nucleus, minus Mn Az plus 1, this is the final nucleus or daughter nucleus, minus Me, this is total delta M into c square. If the masses, if you consider the atomic masses, then you can express this as q beta minus is equal to m of Az minus Z into Me, because electron mass to be subtracted, atomic mass there, electron mass also considered. Here atomic number is Z, therefore Z number of electrons exist, each electron mass Me, then total electron mass Zme, therefore when it is replaced by m of Az, we have to subtract Zme, electron mass we are subtracting, minus it is m of E Z plus 1 Z plus 1 minus comma minus Z plus 1 into Me minus Me into C square. So that equals to m of Az minus Zme minus m of Az plus 1 m of Az plus 1 minus z plus 1 into Me minus Me into C square. Okay, so from this m of Az minus m of Az plus 1, right? Here minus Zme, by separating these terms, minus Zme minus Mu, we will get minus 2Me into C square. So this is the disintegration energy of beta minus decay process. So where Q beta minus greater than 0, when m of Az greater than m of Az plus 1, then Q beta minus greater than 0. That is, so if it is greater than 0, then the mass of the initial nucleus greater than the mass of the final nucleus or daughter nucleus through by the amount to 2Me, then the beta minus decay takes place. So by greater than 0, you can write m of Az minus m of Az plus 1 greater than 2Me. But electron rest mass energy equals to 0.511 MeV. Then 2 MeV, 2 Me is equal to 1.0, 2 1 are 2, 2 1 are 2, is 1.00022 MeV. So if the difference of mass of the parent nucleus and the daughter nucleus is greater than 1.022 MeV, then it is very clear the beta minus decay process takes place. So this is the disintegration energy in the beta minus decay process. Now coming to the beta plus decay process, what is the disintegration energy? So for this, the representation of this reaction ZXA gives rise to plus 1 beta 0 plus Z minus 1 YA plus neutrino, where it is neglected, right? You can write it as ZXA gives rise to plus 1 beta 0 is positron plus 1 E0 plus it is Z minus 1 YA. Okay. Again, this is initial nucleus, it is the final nucleus or daughter nucleus, this is electron. If their nuclear masses are denoted as, it is Mn of Za, electron mass say Me, here the daughter nucleus mass Mn of A Z minus 1, okay. Then what is the mass defect? Delta M is equal the parent nuclide mass minus the total mass of the products, Mn of Za minus Mn of A Z minus 1 minus Me. This is the mass defect forming in the beta decay nuclear reaction. So here, then according to Einstein mass energy relation, for this mass defect equivalent energy, that is called disintegration energy, Q beta plus is equal to delta m into c square, delta m into c square. So then you can write, that is, what is delta m? Mn of ZA minus Mn of AZ minus 1 minus ME into C square. Again, by considering the atomic masses, then Q beta plus is equals to, so this will be M of ZA minus, since there is the atomic number Z number of electrons exist, each electron mass Me, total electron mass Z into Me, so we have to subtract that one, minus Z Me, minus. Here also we are taking atomic mass, then M of A Z minus 1, M of A Z minus 1 minus Z minus 1 into Me minus Me whole into C square, right? So then that gives Q beta plus is equals to M of Q beta plus is equal M of ZA minus ZME minus M of AZ minus 1, M of AZ minus 1, M of AZ minus 1, minus into minus gets plus, Z minus 1 into ME minus minus ME into C square, So this is equal the atomic mass of initial nucleus of M of ZA minus Z into Me minus M of A Z minus 1 plus this is ZME minus ME minus ME into C square, ME into C square. So then what we get here from this, plus ZME minus ZME cancel, right? So this is equals to minus into minus gets plus, right? That equal to M of ZA minus M of AZ minus 1 minus 2ME into C square, minus 2ME into C square. So is it correct? So here M of ZA minus M of AZ minus 1 minus that, M of ZA minus ZME minus, so this is written as M of AZ minus 1 minus Z minus 1 electrons total mass, Z minus 1 into Me minus Me into C square. Then here minus this, minus into minus have written plus, okay, minus ZME, then plus ZA minus ZA cancel, minus Me minus 2Me. So in the previous in beta minus decay, what we got? Minus 2Me. Here also we got the same. So this is M of AZ minus ZME. This is M of AZ plus 1 minus Z plus 1 into Me minus Me into C square. M of AZ minus ZME minus M of AZ plus 1 minus into minus gets here plus, Z plus 1 Me minus Me C square. So then minus ZME plus ZME cancel, here plus Me minus Me cancel, it is not there. So simply Q beta minus is equals to M of AZ minus M of AZ plus 1 into C square. So don't this one. So here Q beta minus equal M of AZ minus M of AZ plus 1 into C square. So what is M of AZ? This is the atomic mass of parent nucleus. It is the atomic mass of daughter nucleus. Simply the difference of initial nucleus minus final nucleus into C square atomic masses. So here we got minus ZME. So this is equals to, here we got M of ZE minus M of AZ minus 1 into this one. So when Q beta plus greater than 0, from this it is very clear, M of ZE minus M of E Z minus 1 minus 2ME greater than 0. Greater than 0. Then M of ZE minus M of E Z minus 1 greater than 2ME. Here that condition is obeyed. So what is that? The difference of atomic mass of parent nucleus and the daughter nucleus greater than 2 times to the electron rest mass, then the beta plus decay takes place. Okay, so this is the beta plus decay. The third one is electron capture. In the electron capture, the equation is Zxa plus electron. This is electron in the K shell will be absorbed by the proton of the nucleus. Then you get Z plus 1 Ya plus neutrino. So this neutrino is neglected. Okay, so here internal equation is proton plus electron in the K shell that will be captured by the proton of inside the nucleus. Then it changes into the neutron plus neutrino particle will be emitted out. Okay, you know, in the beta minus decay, neutron converting into the proton, then along with that electron and antineutrino are emitting. In beta plus decay, proton is converting into the neutron, then positron and neutrino particle are emitting. In the electron capture, the proton of the nucleus, when it is having the more energy, that can capture the electron which is revolving in the K shell of the atom, so that changes into the neutron. So when it proton changing into the neutron, the number of neutrons inside the nucleus 1 decreases. Therefore atomic number increases by 1 unit. Okay, same, let us write their masses. It is initial nucleus, it is the final nucleus, or it is a parent nucleus, it is a daughter nucleus, right? Then what we write, if you write their nuclear masses, here masses by writing, it is Mn of Az, electron mass Me, daughter nucleus or final nucleus mass Mn of Az plus 1. Here it is neglected, it's because its mass is 0. Now the delta M mass defect is equal to Mn of Az plus Me, left side, minus right side the mass Mn of Az plus 1. Okay, this is the mass defect forming in this nuclear reaction. Then from Einstein mass energy relation according to equal mc square, the energy released in this process, that is disintegration energy, equal to delta M into c square. That equals to Mn of Az plus Me minus Mn of Az plus 1 into c square, right? So again, by writing this in terms of atomic masses, you can write QE is equals to, here we are writing M of Az minus electron mass should be subtracted, that is Z into Me, plus here M you write as it is, minus it is M of Az plus 1, okay, M of Az plus 1 minus Z plus 1 electrons mass Z plus 1 into Me into c square equals to M of Az minus ZMe plus Me minus M of Az plus 1 minus into minus plus Z plus 1 into Me into c square. Okay, are you following? right? So what I am saying, are you following? Right, that equals to m of e z minus zme plus me minus m of e z plus 1 plus zme zme plus me into c square. Okay, here plus zme minus zme cancel, right? So then what left? Then QE is equals to m of a z m of a z m of a z minus m of a z plus 1 m of a z plus 1 plus me into c square. So this is the disintegration energy of electron capture. So from this, when QE greater than 0, we can write m of a z minus m of a z plus 1 plus me greater than 0, right? Plus me, right? Here it is minus into minus, minus, this is plus me plus minus zme plus zme, okay, plus me put mate pale, okay, right? So this is, in this way we can do the disintegration energy, or we can calculate the disintegration energy in electron capture and beta decay process and beta plus decay process. So what I am saying is, here 3 points I want to tell you. Beta decay process is 3 types. One is beta minus decay, beta plus decay, electron capture. So in the electron capture, there's something we missed. So that is what, here binding energy of electron should be subtracted, because this electron is a cation electron. So we should write minus Be here, minus Be here. So then finally you will get m of az minus m of a m of az minus m of az minus 1 plus 2me plus 2me. I think so this part will be discussed tomorrow also, right? Thank you.